In this first video for section 4.2, constant percentage change, you're going to learn about percentage growth rates versus growth factors. You should remember growth factors from the previous section where we learned about exponential functions and exponential growth. An important thing to remember about an exponential function is that it changes by constant multiples of a, where a is the base of your exponential function. For exponential growth, the base was the growth factor. That was another name for it. So let's take a look at percentage growth. We're going to work through an example. Suppose you have a stock investment that is growing at 6% per year. Let's work through the math of what happens over the course of a single year. You still have what you started with, 100% of the original investment, and you've added 6% of the original investment. This is the growth. So if you put those two together, 100% plus 6%, you get 106% of the original investment. So what this means is if you want to find the value of your stock investment after 1 year, you'll have to multiply the amount of your investment by 1.06. So I've taken the percent, 106%, and converted it to a decimal to get this multiplication factor. Here's a summary of what we did. And this might be helpful when you're working through your homework problems. If a quantity is growing with a discrete, and in this case that means a yearly, monthly, daily, it could be weekly even, with a discrete percentage rate as a decimal r, then the growth factor is 1 plus r. So relating back to what we just talked about in the example, our growth rate was 6%, and if you convert that to a decimal, it's 0.06, and if you add 1 and 0.06, you get this multiplication factor, 1.06. Let's continue thinking through our example. Suppose that you invested $2,500 in the stock that is growing at 6% per year. I want to work out a formula for the amount that my stock is worth. Thinking back to the previous section where we learned about exponential growth equations look like this. The current value, that's our function, is equal to the initial investment times the growth factor, and then we put the number of years in the exponent. So this is the base of our exponential function. If I plug in the values from this particular example, we'll put in the initial investment of $2,500 and then the multiplication factor, or the base, of 1.06. We get this function. A, that's what I'm calling my current value, is equal to 2,500 times 1.06 to the t power. So what happens after 10 years? So suppose I made this investment in stock and I just let it grow for 10 years. Well, we have to plug in 10 into our function, and I've used functional notation to represent that. A of 10 is equal to 2,500 times 1.06 to the 10 power. This is something that you'll want to put in your calculator, and once you do so, you'll see that the amount after 10 years is $4,477.12, and here I've rounded to the nearest cent.